G'day, it's Chris the Guitar Amp Tech from Sydney, Australia, and I am excited! Excited because it is VibroKing Part 2 day. Even more excited because this has arrived. The Reverb Transformer. So hopefully, if we have any more surprises, this will be finished today. Let's have a look at where the wires from the Reverb Transformer are coming through. Here they are, just here. And we've got 4 wires. And as you can see, the green and the black go to the RCA, which will be heading off to the Reverb Tank. So we know these are the secondary of the Reverb Transformer. So just so I remember the colours, I'm just going to snip that off there, snip that off there. And we've got a little trail there for us. So the other 2 wires, the red and blue, will be the primary. And you can see here, the red is going to the, we'll call it the B plus of this little circuit. And then it goes through the primary of the Reverb Transformer. And then, just like any single-ended amplifier, it'll then come in to the power tube. In this case, it will now be the correct 6V6 instead of the incorrect 6L6. And I'll just leave those stubs there so I can remember where it goes. There's a little Reverb Transformer, just about got this out. And it's just sheet metal screws, not ideal, but there's not much weight in it. Snug that up tightly without stripping the thread. I'll just apply some nail polish to that just to sort of hold it in place. You can tuck down there. There you go. And I'll flip that over. I'll just try and get rid of some of this solder on this RCA connector. Green wire going in there. Beautiful. All right, next will be the black wire to go there. And then I'll put the red wire where that one's going and the blue wire back here. I finished installing the Reverb Transformer. So it comes out here, connected to the RCA here. The blue's connected to the 6V6, which is going to be driving the transformer. And I've got the red wire picking up the power going here, so that's going into the top of the primary of the transformer. In fact, I'll show you. So that's the wire coming into the top of the 6V6. The red is going to Z, node Z, which is the second highest voltage in the amp, B plus being the highest, going to the primary of the output transformer. What's coming on the other side, which is actually driving the reverb, is green and black. Green and, where's the black wire? Black, going to a ground point there. All right, now we're going to power it on. I've got a speaker plugged in. I've put in a new 6V6 in for the reverb driver tube, what should be there. So before I go plugging in the reverb tank, I'm going to use one of my adapter collections, which is going to go from RCA to 1/4 inch phone jack. I'll plug this into the reverb, well, it's called reverb in because it's going into the tank. It's all relative to the tank. And this is now going to plug into this, quite an old computer speaker by a company called Aaron, a well-known Australian hi-fi speaker maker. And I'm hoping that when we turn this on, we're going to hear the sound coming out of the speaker, because we're going to use the speaker instead of the reverb tank. So that speaker is going to go there. If I was just to plug this in right now, and assuming that the amp is all working, we're going to be flooded by the coming out of here. So I've pulled the phase inverter out, which is going to basically eliminate what's coming out of the speaker. Another difference in this amp, so many differences between this and a normal Fender amp. A normal Fender amp has the last preamp tube before the power tubes, being the phase inverter, but in this case it's V5, the second from the end. Voila, V5. If all is going well, we should only hear what's coming out of the Reverb Transformer. This is a bit different to a normal Fender Reverb circuit where you've just got a knob called Reverb, which basically mixes your reverb wet signal with your dry signal. This one's a little bit different. We've got a control here, which is the dwell. So it's basically the volume control of that 6V6. So it's controlling how hard we're going to push that 6V6, which in turn will control how hard we're pushing the input of the reverb tank. Then on the outside of the reverb tank, we've also got a tone control and a mix control. Two very nice features. Well, mix is what we'd have on a standard amp, but we've got tone as well as mix as well as dwell. If I don't turn this up, no signal's going to be going in there, so we're not going to hear anything coming out of the speaker, which I've got attached there. Well, the volume I can turn anywhere because we've got no phase inverter, so irrelevant where I turn that. So I've now got the speaker hooked up to where the reverb tank would be. So if I turn up the dwell, there it is. That's our signal coming into the reverb tank. So we are now confident that that new reverb transformer is working. I will check to see what the output signal looks like, but I suspect all is well. It sounds nice and clean. I've put the phase inverter back in, so the amplifier is amplifying. The reverb driver is reverbing. Tremolo. I did put in a brand new opto isolator. As you can see, there's no leaking light there, but we're still getting a ticking sound. We have that tremolo tube oscillating, created by the phase shift of these three capacitors here. But that ticking is caused by this little neon light. That's a light-dependent resistor, so as the light turns on, that resistance value changes. When the light turns off, the resistance goes the other way. What happens is this neon element, when it collapses, it can create this ticking sound. So what we will do now, we know that there's now nothing wrong with the opto isolator. That's a brand new one. To remedy the ticking sound, I'm now going to put a capacitor, that fella, 0.01 will do it, across the neon side of the opto isolator, and that will effectively snub out the ticking sound. We hope. Got a whole bunch of different capacitors I could use that would do the job. Fender have mainly used these brown ones, fairly inexpensive. I've got these here. As our sound does not pass through this, I'm perfectly happy to use that in this application. And the objective, as always, is to make it look like no one's been in here. And if I put that across there, no one will know the difference. How hard can it be? Now I know how hard it can be. I'm not going to tell you how many hours I spent trying to solve this. It's just too embarrassing. I replaced it with a new one, still ticking. I replaced it with an LED one, still ticking. I replaced it with yet another neon optocoupler, still ticking. I thought, okay, I'll try the old capacitor across the 10 meg, still ticking. Tried different values of capacitors, tried grounding the capacitor at different places, anything to try and squelch that ticking sound. None of it worked. Okay, try lead dress. So I liberated this wire, moved him around, moved all the other wires around. So then I started jiggling around here, and don't laugh, but the closest I could get it to half the ticking level, maybe a third of the ticking level, is putting that opto isolator in a downward dog position. I had the leads a bit longer than I need to, but when I was pushing that around, I found by getting it in the downward dog position, it was actually a little bit quieter. And this oddball position is actually the quietest I can get it. And that's on volume. So with it on volume 2, the ticking is acceptable. If anyone knows how to get rid of it on a VibroKing, please don't tell me about putting a cap across the 10 meg. Please don't tell me about lead dress. Please don't tell me about replacing that. Tried it all. If you have a real solution for a VibroKing Tremolo Tick, I would love to know. But this is about as good as I can get it. A hell of a lot better than it was. Next thing I'm going to do is try his reverb with his Reverb Tank, and hopefully that tank's okay. The owner got back to me and said he's authorising the replacement of the two 6L6s because they're so microphonic, and also one of the preamp tubes is just ringing and pinging away. So I'll replace those two, bias the tubes. I tried the Reverb Tank. The Reverb Tank doesn't work, even though the Reverb driver works. So I tried my workshop Reverb Tank, and that works just fine. So I've got a spare tank, I'll put that in. I've got the bias probes plugged in to my new set of JJ 6L6s. So these are going to be out of sight, you can't see them. Perfectly matched. Look at that, 39 milliamps each. I don't know if you can see that or not. What, out of curiosity, what bias voltage have they got it set at? Minus 43.5. The schematic suggests minus 46. So it's a little bit hotter than recommendation. Let's just do a quick comparison to the power by current. So we've got 0.039 by 436 volts, 17 watts, sounds pretty good, divided by 30 for a 6L6, 57%. That's pretty bloody good. I don't know that we're going to be going far from there, but because I want to get it exactly right, we're going to use my oscilloscope method and then compare it with the current and the voltage. I just want to set the bias to the coldest level. That's minus 70, geez, got a lot of range in it. Needless to say, judging at the current, it's turned the tubes off. So I expect we're going to see a whole bunch of nasty crossover distortion. That, ladies and gentlemen, is crossover distortion. Right there in the middle, where one tube is turned off before the other one has turned on. That is singularly unpleasant. Dare I say, I don't want to incur more wrath of Mesa Boogie fans, but this is the only way that Mesa Boogie can say you don't need to bias tubes, and that's by biasing them so cold that they will never red plate. And we do see that nasty crossover distortion on Mesa tubes, Mesa amps. So I'm now going to slowly increase the bias, making it more positive. And we're looking for when that crossover distortion disappears. Okay, that's pretty much peaked us out. All right, I'm pretty happy with that. We've got a nice clean signal all the way up to maximum, which is happening at 10.2 volts. 10.2 squared, well, we know that's going to be just over 100, divided by 2 ohms. And the reason I've selected my load to be 2 ohms because we've got 3 8-ohm speakers here, which is going to be around about 2.3, I think. So 2 ohms is the closest, and we know that's going to be just over 50 watts. 52 watts. Not freaking bad for 2 6L6s. We are reading 33 milliamps at 441 volts. 0.033 by 441 is 14. Wow, that's gold. That's 48%. What is our voltage? Oh, you got to give it to Fender. You just got to give it to them. Goodness gracious. You're not going to believe what the voltage is for the bias voltage. Remember the book value says 46 minus 46. It was minus 45.9. And I'm seeing no crossover distortion. We're going to run those tubes nice and cool, plenty of life. I'm very happy with that. Rumour has it that he liked the feel of having double stacked pots for everything. And here they are. And he's paralleled them up. He's not just using them as a dummy physical load. So I'm assuming he's perceiving some reliability issue because we've doubled the power of each of the pots for a start. So I'm assuming he's got higher resistances, which is then paralleled off. So I'm now going to clean twice as many pots as normal. Then I'm going to clean the tube sockets, the input jack. I've got to clean these very important send return jacks, of which the return jack is even more important because your entire sound goes out the send, well, it doesn't go out the send, but it goes from that contact at the send to that grounding leaf, or whatever you call it, then into the next stage. So it comes through there and onto that next stage. That socket especially, the return one, and you'll find this on a lot of amps. So if you have an amp with a send return jack, just make sure that that contact is got a good secure contact and that it's very clean. It's done. I ordered a new Reverb Tank for it, an MOD one. Fortunately, I was able to actually repair that one. Doesn't always happen, but in this case, that was a successful repair, so this is going to stock, and it saved the customer a few bucks. I think we just need to, God, it's quiet. It's quiet because I'm not plugged in. But it's still a quiet amp, jeez. Well, I did do a fair bit of work to it, didn't I? For those of you that know me, I'm not much of a reverb fan. None of my amps have got reverb built in. Is that true? Oh yeah, my AC10 has got a digital reverb, which is not bad. But none of the other amps have reverb. I've never really been a reverb user. So it doesn't take much reverb for me to go, nah, too much. Having said that, I have just discovered this little TC Electronic Hall of Fame pedal. I'm actually now using a tiny little bit of plate reverb. Being so based on that early 60s, you know, Bandmaster 3x10 with the separate reverb unit, definitely it's a nod to the surf era. This just doesn't look right, does it? like all those reverbs. This thing sounds fantastic. Let me just turn some of that reverb down. Fantastic, isn't it? All right, that'll do for this video. The VibroKing sounds phenomenal. If you've gotten anything out of this video, can you please give it a like? If you haven't already, can you please subscribe? And I look forward to seeing you at the next video.